Calc AB. So we have 3 problems to go through together. A rectangle has its base on the x-axis and its upper 2 vertices on the parabola 6 minus x squared. What is the largest area the rectangle can have and what are its dimensions? Justify your answer. So here's the visual of the rectangle fitting inside of the parabola 6 minus x squared. Remember that this is not the only rectangle that can fit, that really there's, another one that could be here. There's even a wider one that could be here, and so that's something that moves around. And so it doesn't stay put. And so that's our job, is to figure out what rectangle is going to have the maximum area. So let's start by figuring out the dimensions of our rectangle. So we're going to call this x, and because of symmetry, this is also x. And up here, this is a point on our parabola. So the ordered pairs should be x and then 6 minus x squared. The length of this side, or the height of this rectangle, is also going to be 6 minus x squared. So the area of our rectangle is 2x, because together those make 2x, times 6 minus x squared. Type this into y1 in your calculator and have it take a derivative for you. Remember that when you're writing out a problem, it's really important that you write out that step, that even if you have a calculator doing a lot of the work for you, you're still interpreting all the calculus. So you need to tell it to take a derivative, and then you're also setting your derivative equal to 0. So in your calculator, we'll type 2x times 6 minus x squared. Turn it off. And graph. All right, I'm going to find this intersection over here because we're dealing with a rectangle. We only have to deal with the positive x's because it's a geometric figure. All right, so 1.4142. My calculator was a little slow. So we can make a sign chart on area prime, put in 1.4142. This is 0. Looking back at my graph, I have a positive derivative before and a negative derivative after. And that's a good thing because they're asking us to find the largest area, which translates into the maximum. So the maximum area is, remember that your calculator has in y1 our area function. So we can say y1 of x, and that's equal to 11.3137. With dimensions, because they're also asking us for dimensions. (2x) by 6 minus x squared, and so I can use my calculator to help me with that as well. So we have 2x, 6 minus x squared. And then the because. The because is the justification, so it's not just the answer. The justification is writing a sentence explaining the calculus and how you know that's your answer. So because area prime changes from plus to minus at x equals 1.4142. I think that this step here is actually a really important one in this problem in particular, because they ask us for the largest area and they ask us for the dimensions, and none of those values are the 1.4142. So I think it's just an important thing that you finish your justification with looking at that x value. All right, so that's number 1. Number 2. Same kind of situation. It's just that we have 2 parabolas this time. A rectangle is inscribed between the parabolas y equals 24 minus x squared and y equals 2x squared. What is the largest area the rectangle can have, and what are its dimensions? Justify your answer. So we still have a rectangle, and so the area of your rectangle is still going to be base times height. And our base is still going to be the x and the x like we had in our last problem. What's more challenging is how you can come up with the height of this side. And so the first thing I'm going to do is bring down that y value. So forget about anything else except the height of that parabola, and so that represents this pink right here. And then the height for the green one is right here. And so I hope you can see that the height of this rectangle is really just the difference between those function heights. So it's going to be the pink distance minus the green distance. Another thing to consider is which of these functions is on top. And looking back at their coefficients, I know that this function on top is 24 minus x squared, and the one here underneath is y equals 2x squared. And it's because negative coefficients on x squared will open down, and positive coefficients on x squared will open up. So that's going to be your height of your rectangle. So we have 24 minus 3x squared. The area of my rectangle is 2x times 24 minus the 3x squared. Put that into y1. Let it take a derivative and set that equal to 0. Okay, graph it. Find your intersection over here. Just like in the last problem, we don't have to worry about the negative because we have a geometry context. All right, so x is equal to 1.6330. And the derivatives were positive before and negative after. So now we're ready to write our sentence. The max area is, so you can go to your home screen, bars, y bars, y1 of x. And let's just do the dimensions right away. So we have 2x, and the height is the 24 minus 3x squared. Because area prime changes from plus to minus at x equals 1.6330. All right, question 3. Which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? All right, so here we have the word closest, and closest implies minimum distance. All right, so then the next thing we have to consider is the distance from the point 0, 2 to some point on the parabola. And just like with all the rectangle problems, that point doesn't have to be there. That point could have been here, or it could have been here. What I'm doing is I'm just plotting one of them so I can understand what I'm trying to do. So this represents the distance, because distance is always straight line distance. And I hope you remember from geometry that when you find distance, you're always using this formula, the change in x, change in y, and then it's really just Pythagorean theorem. And this is like a messy formula. I'm not even really going to use that for this problem, but because I think it makes more sense just to talk about it in a different way. So here's the point 0, 2. And this point is the point x and 4 minus x squared. So every single one of our right triangles, every single one of them is going to have a width here of x. And just like in the rectangle problem we had before, this represents the height of the parabola, and this represents the height of 2, right? Because every single point has to be figured out relative to the point 0, 2. So the height of my right triangle within here is 4 minus x squared minus 2, which is the same thing as 2 minus x squared. Okay, so then the next thing we have to do is figure out the distance between the point 0, 2 and this point over here, because the question asked us for the closest point. Now, here's an interesting idea, that if you have this distance that you're trying to minimize, you may as well consider distance squared, and it's an easier approach, because if you're going to minimize d, it's exactly going to be the same value as minimizing d squared. So make life easy and just use Pythagorean theorem here. So you'll have x squared for this width right here, plus 2 minus x squared squared. And that's just your right triangle. So this is what's being minimized. This is what gets to go into y1. And then you are going to have your calculator take the derivative and set it equal to 0. I hope you can see that this Pythagorean theorem is easier than manipulating this distance equation. I think either method is fine, just realize that they mean the same thing, but some people like to have a formula for that. I don't think you need to do any simplifying at all, like expanding and simplifying before you plug in. I think let the calculator do as much of that for you. All right, calculate the intersection. I'm going to find this one over here this time. I think in this case it does make sense to do both the negative and the positive. I don't think you actually have to intersect both of them. I think you need to use both of them in your sign chart. So we have negative 1.2247. The reason I think it makes sense in this example is because, yes, there's symmetry, but there's no geometric figure that you're dealing with here. You're dealing with the distance, and so that distance can also be minimized by somewhere over here. So negative 1.2247, we had a 0, we also have the positive. And your sign chart was negative before, then positive, then negative, then positive. So we have two minimums. You still need to figure out the y value that's associated with these, and that just belongs with that function right there, 4 minus x squared. So we'll type on our home screen 4 minus x squared. And that value is 2.5. So we'll write our sentence. The points closest to 0, 2 are negative 1.2247, 2.5, and positive 1.2247, comma, 2.5. Because d squared prime changes from minus to plus at x equals plus or minus 1.2247. All right, that's it. You've got some homework problems to try. See you later.